Hi, this is Yang,
This is Xiaoming
and this is Jorge Flores, and this is our mid-project proposal.
Our proposed project is integrating navigation application with the 3D audios. Based on the user's current location and the destination they input, we will continuously generating a 3D beep sounds from the direction of the destination. Thus, the user can follow the real-time generated 3D sounds to their destination.
First, the user needs to input their destination, then the system will call the router to map the input to its corresponding controller. The client-side controller will call the server-side controller to get the latitude and longitude of the destination from the database. And the server-side controller would also start to load the original sound file. The data would be sent back to the client-side controller. After receiving the data from server-side, the client-side controller calls the Google Map API to get users' current location and facing direction by accessing phone's campus. The 3D sound process would occur in the client-side controller.
This is a GUI for our application, and this website is actually being published. The homepage is a list of all the buildings in the UF campus. User can also use the search bar to search the buildings. Once the destination is selected, so the user will be navigating the second page, where the 3D audio will be like automatically generated based on the user's location and the destination. So is this a real-time generating of the 3D audio continuously based on the because the user will keep changing its locations. Um, and the direction like 9 o'clock, 12 o'clock is used just to enhance the navigation ability since the user might missing the 3D audios. From the biology paper, using 3D sounds to improve the effectiveness of the advanced driver's assistance systems. We know that 49% people are able to distinguish the 3D sounds from the 45-degree angles. So we divide up our coordinate system into 8 sections. It is like the north, south, east, west, southeast, southwest, northeast, northwest. So initially we are thinking to generate different sounds from different buildings. However, it will create just too much confusion and the sound resource is also limited. So we try to use one standard beep sounds, which is less likely to mix up with the other sounds from the street, and it's also familiar to the users.
Procedure. The participants are divided into two groups. The first group will use our app to walk from in front of Marston Library to Rhines Hall. The second group will use Google Maps to locate the same building. The participants will be selected based on how familiar are they with the UF campus. We will select participants that are not very familiar with campus because that is our target demographic. The purpose of this experiment is to demonstrate that our application will help users to find their destinations much faster and in a more efficient way. To accomplish this, we will measure the time it will take each participant to get to the destination and how familiar was each one of them with UF Campus. Each group will depart from in front of Marston Library, and a member of our team will follow each group to ensure their safety and to measure the time. Once the last participant gets to Ryan's Hall, we will ask them a few more questions about how the application worked for them, and that will be the end of their participation. Statistical treatment. Each participant will have an individual profile with the data we collected from the experiment. We will ask the participants if they are UF students or visitors. If the participant is a UF student, we will ask what year are they in. Also, we will ask them to choose in a scale from 1 to 5, 5 being very familiar and 1 not familiar at all. How familiar are they with the UF campus? Finally, we will measure the time it will take each participant to get to Rhines Hall. With this data, we will not just measure the time it takes for each participant to get to Rhines Hall, but also how familiar they are with UF campus. Because this can also influence the time it will take them to get to the building. After taking these factors into consideration, we will demonstrate that using 3D sound in a navigation application will help users to find their destination much faster.